Hello everybody. Hope you guys are doing well. Just let me check if the stream is up and running. Else, because at times it does not work properly. So let's move this thing here. Okay, just let me check if it's okay. Just give me 1 minute. Yeah. So the stream is up and running. Um. So in the last session we learned that why inheritance is a bad thing, right? But then, even though inheritance is a bad thing, um, still in some languages like JS, right? We um, s- s- cer- certain languages like JS, right? For example, in JavaScript. Now, the JavaScript is entirely based on prototypical inheritance, right? So then, let's understand why. If you are saying that inheritance is so bad, then why do we use a newer version of it or a more advanced version of it called as prototypical inheritance? Like, why do we use that? Like, what's the advantage of using that prototypical inheritance over other inheritance? Because so first, let's study a class-based inheritance. Basically, the main issue with the class-based inheritance is basically the what you say, the base class problem, right? So for example, if this is a parent and then I have a child inheriting from this class, and I have another child inheriting from this. So what does the base class problem states? If I if I make changes to methods present in here, these methods will be reflected in both the child, right? So, however, even if we had intended that change for one particular children, since we are inheriting, that changes will be made available in both, right? So this is nothing but what is some called as a base class problem. So what if, suppose, imagine a situation where we are using a code, and like we are using a method here in class, in my child class A, and then we are modifying that method, and suppose there is another class, child class B, right? What if this makes changes to this method? Now this is what the issue happens is, uh, if we try to change the methods here, it will be reflected in both, right? However, we never intended it for child A class, but still it will occur at child A as well. Now, why is this happening? Because OOP in languages like Java is dynamic. Sorry, is a compile time concept, right? So basically, what it's trying to say is, uh, like the object oriented mechanisms will happen at compile time, or for example, inheritance or that interface checking, that is all going to happen at compile time. Now, what does this do is basically, when we compile itself, we create a dot class file, right? So for each class we are going to create a dot class file, and this dot class file also maintains the relationship between different classes, right? So this is a very big problem, right? Now, so that is issue, this issue is happening at the compile time. Now what if we change this inheritance from compile time to something called as an interpreter type, right? Now, the biggest advantage of doing this is, first of all, we are going to avoid this base class problem, and then we'll see how the base class problem is getting avoided. So, at runtime, what is going to happen is, so for example, this is our block of code, right? So, like, let us assume that this is our block of code. So for example, and this is a single threaded language, that is we are going from top to bottom, right? So the moment we and then we have at line 1 we have a prototype being declared and being modified, and at line 2 again we are declaring, and sorry, we are trying to modify that prototype. The same, both of them are the same thing. So now what is going to happen is the moment we reach this line 1, right? The moment we reach line 1, uh, what is going to happen is, in this is dynamic, or basically the inheritance is going to happen at runtime. So instead what will happen is, here this inheriting, here we would be adding one class, and then the moment that statement is executed, that thing is no longer in my, it will be present in my chain, but then it has already been executed, right? So if there is any child class trying to access it, now it can identify and access it. But then if I come to line 2 and I modify the same prototype, now what is going to happen is the modified version or the new version is now being going to be available. So the base class problem is here eliminated by uh, uh, because the modification is going to occur and reflect only in only after line 2 has been done, right? The modification of line 2 is not will not be shown in line 1, right? So this is basically why we prefer prototypical inheritance, because remember JavaScript was developed basically to make the web more dynamic and intuitive in nature, right? The project JS was started when Randall or basically wanted to have something that is able to show indicate the number of files being downloaded, right? So that is when he started this JS project. So the main goal or main idea of using JS is basically to have this dynamic dispatch facility. That means the inheritance is occurring at runtime, because by doing this we are going to avoid the base class problem. And hence, even though we say that inheritance is a bad choice for programming, the prototypical based inheritance will always be preferred, because this is going to happen at runtime, unlike the class based inheritance which is going to take place at compile time. Okay, now there are other methods of programming languages as well, right? Now event driven. Now event driven languages are those. It's again, this is these are so other than OOP, there are other programming paradigms as well. For example, the first one is basically an event driven programming, right? Now what do we mean by event driven programming is basically what is going to happen is now what is going to happen is, now the flow of the program is determined by events. For example, a user clicked on a button or some other action, for example a timeout occurring out, or some other example. Now the program waits for events to occur and will respond to them. Now these are basically handled by something called as callbacks. Common GUI server-side application, for example a button triggers an event handler. For example, if we are one, for example we have defined a project, right? Now if we press this, but this is a button, let's assume this is a button. Now the project is if this button is pressed more than 7 times, we are going to change the color of this button. So this is basically after the 7th event, what we are going to do is toggle this or change this color to any other that we want. The pros is basically real-time applications can be done. Now the disadvantages of using event-based programming is, now all these events are going to be handled by callbacks, right? So there is one issue, because that one majority issue that we come through is something called as a callback hell. So a callback hell is, what if it's same like an recursive hell problem. What is going to happen is I'm going to nest a callback inside a callback inside a callback and so on, and these callbacks are never going to end. So it will look like a pyramid like shape, right? And the outer callbacks will become dependent on the inner callbacks. So basically, we are achieving tight coupling here. So that is one major drawback of using event driven programming, right? Remember, Node.js is both event driven as well as it is supports asynchronous programming, right? Now, the advantage of using asynchronous is, first of all, we get rid of this callback hell and we handle the code asynchronously, right? By asynchronously, what do we mean is, instead of working on the main thread, what we do is we pull the asynchronous code outside, and will we say you keep on working or keep on consuming. The moment you are available, yeah, contact the main thread, and then I can process it. So by doing this, what are we first of all, what are we getting rid of is this event handlers or callbacks, and then indirectly what you are getting rid of is something called as a pyramid of doom like situation or a callback hell. Now, asynchronous programming is a very basically, yeah. So what is going to happen? Tasks are executed independently of the program flow. By what does he mean by independent is, if this is the main thread, you pop out of the main thread and let the other process continue in the background. As soon as that processing or the data there is available, you come back to the main thread. So basically, this is nothing but what we mean by asynchronous programming. Now, the different types of operations can be performed, right? For example, fetching a data, reading a file. Now, the major advantage is basically, first of all, we are getting rid of these callbacks, and then we are using something called as promises or async await, right? Now, this is not only it makes, now see, we will be blocked in this callback hell, right? The moment we come to this, we are blocked and we are stuck in that callback until the callback is not completed, or we do not resume that callbacks, or the innermost callbacks have been not been worked upon. The outer callbacks will not work, right? So we are kind of leading to a bottleneck here. Now this is avoided in when I do promises and arsing event, right? That bottling is basically avoided, and instead of doing everything in the main thread, we pop out of it and let the main thread work, and whenever our async work is ready, we give it to the main thread. Now callbacks are very easy to write, right? Because these are very these are just like functions, right? But the biggest difference is when you start debugging a callback can be very difficult, because the moment you go into that pyramid of doom, it kind of makes readability an issue. However, in asynchronous programming, the problem that we face is writing the code is a bit difficult, because now everyone is not familiar with how promises works and async and await work, right? So these can add a little bit of complexity when a person is trying to code. However, the biggest advantage or the major advantage over of asynchronous programming is over callbacks or over event-driven architecture is, we are debugging will become very easy, because all these asynchronous operations will not be more than one line. So if you know what output it is going to produce, debugging them will be a piece of cake. So that is what that is why we use asynchronous programming. Now there is one more type of programming called as reactive. Now it's basically similar to event driven. Only difference is you are going to react on certain state changes, right? So for example, JS is not reactive. However, the framework React.js that is developed on this concept where you use a reactive programming feature. Okay, now this is this is basically one of the most important concepts that we will see is basically the observer pattern, right? Now the observer pattern allows the objects that we call observers to listen for and notified for changes in some other object known as observable or the subject. Now the observables push values to their observer so that the observers don't have to poll for changes and then pull values. So basically what we are going to do is uh, this is the observer, right? So this is the person who is observing. So this is the person who is observing, and this is what is getting observed, right? So this is observable. So now what this design pattern states is, or what observer pattern states is, instead of the observing person looking for or polling every time to the observer to check if is there any changes, in this there any changes, in there any changes, what we do is we make the observer call the person we made the object being observed call the observer and say that some uh, changes has occurred to me, please redo some part of your code again. So this is nothing but the core logic of observer pattern, right? Okay, for example, now as per design pattern books, the definition is it defines a one to many dependency between objects, so that whenever one object changes, all its dependencies are automatically updated. So remember, this observing person doesn't have to wait his time to keep on polling, right? That is a very bad method. Now so let's explain a real world example, right? For example, for a podcast app, right? So uh, we don't want the user to keep, it's like push notifications, right? You don't okay, for example, push notifications, right? Now we don't want the for example, this is our app, right? We don't want this app to or we don't so this is my push notifications. Now the we don't want the user to open the app every time and check whether a podcast was related or not, released or not, right? The app should notify the user that, so here the user is person who is observing, right? And the thing that is getting observed is nothing but our application, right? So if we were using here an observer pattern, what that will say is, instead of the user uh, checking in on you, you should notify the user that uh, a new podcast has been released, please come and check me. Same goes with subscribe button, right? You don't want the to keep on checking YouTube, right? You want YouTube to notify you that a new podcast is available, please update me now. What So basically this is the crux of this observer, right? Now this observable pattern is inherently being used in many languages, right? For example, in Swift UI, at the whenever we use the at the rate or whenever we try to do at the rate state, right? Inherently what we are doing is basically we are somehow using this uh, observer pattern and making the what we are doing is basically we are saying that whenever there is a changes in the UI, so basically this is what is my observer, right? So what I am saying is, whenever there is a changes in this, you have to re-trigger the UI or inform me that a change has occurred and re-trigger its formation. This is nothing but what we this is where practically observer pattern is implemented, right? Even in frameworks like React, right? Whenever you do use state or some other hook, what happens is the changes are told to the React, right? Like it kind of uses the define algorithm to change or to check where the specific line or at which specific line the change has occurred. Once it comes to know that this specific line the changes occurred, then the lines below it, all of them will be re-rendered, right? That is a biggest advantage, right? And the lines above it, since these are not dependent, and we are assuming that the lines below are somehow using the state, right? And what if there is lines above it we were not utilizing say this state, we are not going to use this and re-trigger the upper UI, right? That is a very bad form or a bad way of writing code, right? So here is when we practically or those libraries are implemented in such a way so that we can do observation, or you can make use of that observable pattern. Okay, so I guess yeah, that is all for this lecture. I'll see you guys in another video, hopefully to complete OOP, and then we will start with something new. So yeah, that's all for this session. See you guys in the next one. Till that time, take care. Bye bye.